Okay, this is IM2, and this is lesson 7-1. So instead of finishing out the rest of chapter 4, we're going to finish out our talk about triangles as we finish up this distance learning. So I want to jump up to triangles and talk specifically about right triangles. If you recall right triangles, if we wanted to draw a picture of a right triangle, we could say a right triangle is going to be a triangle that has a 90-degree angle in it. We use this statement in our proofs, right? So here's my 90-degree angle. Now, we can make a variety of right triangles from this 90-degree angle. We use the little square to represent the 90 degrees. So we could make a triangle that looks like this, and that would be a right triangle. We can make a right triangle that looks like this, and that would be a right triangle. We can make a right triangle that looks like this, and those would all be right triangles, all of them, right? So the Pythagorean theorem is the statement that the leg squared plus the other leg squared equals the hypotenuse squared. If you recall, the hypotenuse is the side that is opposite of the 90-degree angle. So this is a hypotenuse for this triangle. This is a hypotenuse for the smaller inside triangle. This is a hypotenuse for this triangle right here. All right. If you watched my video, or it wasn't mine, but it was a video I really love about where Pythagorean came up with his theory, it was the idea, and I'm just going to sketch a right triangle, so this is not going to be perfect, but it was the idea that if I have a right triangle, right, the literal square that you make from this side and the literal square that you make from this side, again, those are not perfect drawings, I'm freehanding drawing this, right, is equal to the square that you get when you turn that side into a square. Squares have specific properties. So this leg squared and this leg squared is equal to this hypotenuse squared, right? They're equal. They add to this amount, right? That's the property. We write it oftentimes like this. We say a squared plus b squared equals c squared. Maybe you've seen it before, maybe you haven't and totally forgotten it. But we're writing it like this, where C is this leg, the hypotenuse. Here's my right triangle. I'm sorry, that's a really bad right triangle, but go with it. And this is A and this is B. It doesn't matter which one A and B is. They can be either direction, but that's A and B. So reading straight from your book, this is the theorem. It says that if a triangle is a right triangle, and this only works for right triangles, then the sum of the squares of the length of the legs, the sum is adding. If you add the two lengths of the legs and each one is squared, it equals the length of the hypotenuse squared. Okay? So I turn the page. There are a set of numbers that where when you square them, you get a number that comes out even. I'm going to say that probably 90% of the problems, if you just make them up on your own, these numbers are going to be irrational. It'll be the square root of something. But these numbers, and this is at the top of page 416, these numbers are numbers to look out for. You have the 3, 4, 5 triangle, you have a 5, 12, and 13, you have 8, 15, and 17. Obviously, the biggest number is the hypotenuse. These ones are going to work out perfectly, or multiples of these ones. So you could have a 6, 8, and 10, right? You can have multiples of those ones, but these ones will work out perfectly. All right, so let's try one of the problems. This is the problem 1 on Got It. The legs of a right triangle have the length of 10 and 24. What is the length of the hypotenuse? So here's our right triangle. I'm going to draw it so you have a picture of it. This is 10, this is 24, not to scale. How do we solve for it? You're gonna need your calculator or your phone that has a squared on it or something like that. So we have 10 squared plus 24 squared equals c squared. All right, so we're gonna square those. So we have 10 squared plus 24 squared. The total equals, so 676 equals c squared. If we want to find the square root of that, we find that it's 26. So that means that we take the square root of both sides, and we find that 26 equals C, and that's our hypotenuse. Do the side lengths in form A form a Pythagorean triple? Yeah, it's this one. No, you can't see that. It's this one right here. It's the 5, 12, and 13. This was times 2 times 2, and then this is 13 times 2. All right, let's do practice 1. So we have 8, 15, and x, so we can find it. We can say that 8 squared, and that's the hypotenuse, we know, because it's the one opposite the right triangle. 8 squared plus 15 squared equals x squared. I grab my calculator because I don't want to do this in my head, and I find that 8 squared plus 15 squared equals 225. Remember, do not stop there, right? Because that's the squared. So we need to square root both sides. All right, and we get 15. So x equals 15.